Algebra 2, and welcome to our first video that you guys will be watching at home. And our first video will be covering solving exponential equations and inequalities. But actually, we're going to cross out inequalities. We're going to just cover solving exponential equations for now. So first, let's start off with what exactly is an exponential equation. Now, we might have already covered this earlier today, but just to review, let's say we have a function such that the function looked like this, where it was 3 to the power of x. Now, this is actually an example of an exponential equation because it turns out that our variable is the exponent, not a number like we're used to. And also, while we're on the topic of definitions, since in this case our variable x is the exponent, our number here that's below the x, that is what is called our base. And the base is actually going to play a very crucial part in this lesson of solving exponential equations. So now that we got definitions out of the way, let's move on to the key concept, which is right below. So basically what the key concept is if we have a base, or b in this example, that is greater than 0, and if the base is not equal to 1, then we can say that our base, b to the x, is equal to b to the y if and only if x is equal to y. Or in other words, if our exponents are the same. But to better explain what this key concept is explaining, let's look at the example right beneath it. And basically, the example says, let's say we have an equation that looks like this, where we have 3 to the x, one exponential expression, and that's set equal to 3 to the 5th. From this fact right here, the crucial thing you want to look at is, notice how in this example, our two bases are the same. They're both a base of 3. And it turns out if this happens, we can just go ahead and take our two exponents and just set them equal. So in other words, we would have that x is equal to 5. And just like that, we have solved our exponential equation. We can say, it's solved, we're done, woohoo! So that's the main concept you want to keep in mind here, is if we have two exponential expressions such that the base of each one is the same, then right there we can go ahead and take our exponents, set them equal, and find out what our x value is for our exponential equation. So as long as you keep that main concept in mind, the rest of the lesson is just going to be some practice problems using that key concept. So with that in mind, let's look at our first example. So our first example tells us that is asking us to solve each equation. So let's go ahead and look at the first one. And the first one says that we're going to have 2 to the x, and that's going to be set equal to 8 cubed. Now, right away, if we look at the two bases, we know that they are not the same. One is 2, and the other is 8. However, it may be possible that we can rewrite this equation so that the bases are the same. But for this example, let's take a look at the base that is 8. And we need to ask ourselves, let's look at number 8 over here. Can we rewrite that somehow so that it's a base of 2. Well, as it turns out, well, we all know our basic multiplication. We know that 8 is the same thing as multiplying 2 3 times. Or in other words, 8 is the same thing as 2 cubed. So with this right here, we know that we can rewrite 8 as a base of 2. So this little fact right here might help us out. So now let's bring it back to our equation. 2x is equal to 8 cubed over here. So now let's just take it over a notch and let's rewrite it. So we first have 2 to the x, and that's going to be set equal to the next part. But now we know that 8 is the same thing as 2 cubed. Let's use this fact, and instead of putting 8 there, let's put 2 cubed there. Now don't forget, the 8 was raised to the cubed power already. So in other words, that 3 on the outside is still there, along with the power of 3 that we got by changing 8 to 2 cubed. So now, instead of 2 to the x equal to 8 to the third, we now have 2x equal to 2 cubed raised to the third power. And then from here, we might want to take care of this cubed raised to the cubed. And just using our algebra skills we learned recently, we know that we'll have to multiply those powers because it's a power to a power. And by doing that, we'll now have 2x equal to 2 to the 9 because 3 times 3 is 9. And check it out. We now have 2 to the x equal to 2 to the 9. Our bases are the same, which means we can just take our exponents and set them equal. So in other words, x is equal to 9, and we have just solved our first exponential equation. In this case, our final answer is x is equal to 9. And if you're ever curious on whether or not you got the right answer, you can always double check your answer if need be. So in other words, you can take this x equals 9, plug it back into the original equation up here, and see if it's correct. So just out of curiosity, let's go ahead and do that. So right underneath, instead of 2 to the x, let's put 2 to the 9th, and that's going to be equal to 8 cubed. And then if you have your handy calculator with you, you can find out that 2 to the 9th is equal to 512. And then you can go ahead and check 8 cubed, which is also, again, 512. So just by checking that, we see that 9 is indeed the correct answer for this equation. So it's actually not too bad. Just make sure your bases are the same by rewriting your bases. Or in other words, try simplifying your bases. And then just set the exponents equal, and you can find your x value. So now that we got that example out of the way, let's go ahead and start on the second one. Let me go ahead and draw a barrier. So now we'll look at the next one, which says 9 to the 2x minus 1 is equal to 3 to the power of 6x. Now we're taking it up a notch with this example because it's not just bases raised to a power of just x. We now have expressions as exponents. So first things first, let's go ahead and look at our bases. And sure enough, they are not the same. So we're going to have to rewrite this equation so that the bases are the same. And usually the trick is you want to start with the bigger base and try and make it match to the smaller base. So let's just go ahead and start with 9 because it's the bigger base. And as some of you already know, 9 is the same thing as 3 times 3. Or in other words, 9 is equal to 3 squared. And that's what we want in order to rewrite it. Rewrite 9 as a base of 3. So let's go ahead and use that fact. So instead of having a base of 9, let's rewrite 9 as 3 squared. Now let's go ahead and put parentheses around that so that we can go ahead and put our original exponent on the outside. And that's still going to be equal to 3 to the 6x. And then while we're at it, let's go ahead and multiply this 2 to our power of 2x minus 1. Now you'll want to make a mental note right here. When you multiply the 2, you got to make sure you multiply it not only to the 2x, but also to the negative 1. So in other words, you have to distribute it. If you don't multiply it to both of them, you will get an incorrect answer. So over here, let's just go ahead and do that. So then we'll have a base of 3. If we multiply the 2 to the 2x, we get 4x. And then multiply the 2 to the negative 1, you get minus 2. And then just set that equal to 3 to the 6x. And look at that. Our bases are now the same. So go ahead and just set those exponents equal. And let's go ahead and solve for our x value. So our first exponent is 4x minus 2. And we're going to set that equal to 6x. And then here we just have a regular equation that we just need to solve for x for. And there's more than one way you can do it. You can minus the 4x over or minus the 6x over. But in this example, I'm going to subtract the smaller one to both sides. So then the 4x and the negative 4x cancel on this side. And then we'll still have a minus 2 on this side. And 6x minus 4x is equal to 2x. And then, just to get the x alone, all you need to do is divide by 2. And from there, you get x equal to negative 1. And voila, you have your final answer. X is equal to negative 1. And as always, you can't, if you want to, you can double check your answer by plugging it back into the original equation up here. But I will let you guys do that on your own. But for now, I'm going to let you guys try an example on your own. All right, you guys should have finished your example by now. If you got it correct, good for you. If not, go ahead and watch me solve it, and hopefully you can see where you went wrong. So in this example, the example you just did, you did 4 to the 2n minus 1 equal to 64. And with the 64, it doesn't, you can't really see that it has a base, but you can assume 64 is raised to the power of 1. Because 64 to the power of 1 is still just 64. And as we can see, the bases are not the same. So let's go ahead and take the bigger base and rewrite it as the smaller base. And if you want to check, 64 is the same thing as 4 multiplied by itself 3 times. So in other words, 64, that looks like a 9, let me fix that. 64 is the same thing as 4 cubed. So let's use that fact to help us rewrite our equation. So we'll have 4 to the 2n minus 1. And instead of 64, let's go ahead and put 4 cubed. And from there, sure enough, our bases are the same now. So all you need to do is set the exponents equal to each other and just solve for n. Let's go ahead and do that. We'll have 2n minus 1, and that's going to be equal to 3. Then from here, just solve for n by getting that n alone. Let's go ahead and take care of the minus 1 by adding it to both sides. And by doing that, we'll now have 2n equal to 4. And then all you need to do is just divide by 2, and you get n is equal to 2. And again, if need be, you can always double check. So now go ahead and try the last one on your own, and then we will check. We'll go over it once you are done. All right, welcome back. You guys should have answered the Ed puzzle question by now. If you got it right, awesome. If not, let's go ahead and look at this example again. What I meant is let's go through this example. Hopefully you can see where you went wrong. So we have this equation, 5 to the power of 5x equal to 125x plus 2. And again, the bases are not the same. And let's start with the bigger base and rewrite it as the smaller base. So we know that 125, if we multiply 5 by itself 3 times, we actually get 125. So 125 is the same thing as 5 cubed. So that is what we will need to help us solve this equation. So let's go ahead and use that to rewrite our equation. 5 to the 5x. And instead of 125 over here, let's have 5 cubed. And then on the outside of the parentheses, we'll still have the x plus 2. All right, and before we can solve for x, let's go ahead and multiply this 3 to the x plus 2. And don't forget that 3 needs to be distributed to the x and to the 2, not just the x. So let's go ahead and do that. 5 to the 5x. And then over here, we'll still have a base of 5. 3 times x is going to be 3x. And then distribute the 3 to the 2, which becomes a positive 6 or plus 6. All right, so our bases are the same, 5 and 5. So now just set the exponents equal, and let's find that x value. 5x equal to 3x plus 6. Now just subtract the 3x to both sides. Or if you subtracted the 5x to both sides, that is also correct. You'll still get the same answer. But for this example, I just subtracted the 3x. So then 5x minus 3x is 2x. And over here, we still have 6. Then just divide by 2 to get the x alone. And 6 divided by 2 gives us x is equal to 3. So again, if you didn't get that, write a mental note on what you missed. And if you weren't sure where you went wrong, put a question mark next to this one, and we can talk about it in class tomorrow. So just to wrap up, here's the assignment that we'll be working on in class tomorrow. If you want to go ahead and get a head start on it, you can. If not, we will have the hour to work on it and discuss it with friends, partners, and with me. Other than that, I will see you guys tomorrow.